In this video, I'm going to go through what you need to know in order to complete the 8B lab, which is extra credit. You'll have 2 t-tests that you'll need to run, and then you'll need to do 2 of these tests, which is going to be a chi-square test. Now, just like with the confidence intervals, chi-squared is a little different than the other ones. Here's an example, and then we'll walk through another example that is written on the project. We have 40 people use the Weight Watchers diet for a year. Their weight losses had a standard deviation of 4.9. And we want to, with a 0.01 significance, we want to test the claim that the amount of weight loss of a standard deviation is equal to 6 pounds. So we'll kind of start off the same way, in that we'll start with what we're saying our claim is that our standard deviation is a 0.6. That will definitely be my null, as that has the equal sign, and so then the opposite is not equal to. And so that will be my null, my alternate. I have a two-tailed test. And I have 40 people here, so DF will be 39. And I want a 0.01 significance, so that means there's 0.99 in here, and then there's 0.005 on each side, right? Because I got to take that 1% and break it up. And so what I need to do now is find these critical values. The calculator is not going to find a test stat for you. It is not going to find p-values. It's not going to do any of that. This needs to be done by hand. Allegedly, with the textbook, you can download to your calculator program to do this for you. I only know one person that ever tried to get it to work and actually had it work. But you're more than welcome to try to get it to work. To get these values, we're going to go to that same chart that we used for the critical chi values on the confidence intervals. And we're going to find those cutoffs. Now remember, this guy runs backwards. So to the right of the critical value over here, to the right of this is a 0.995. 0.995, this first one, and I have 39. Okay, well, we don't have a 39, so we're going to use a 40. 20.707. And so this guy is a 20.707. And then this guy over here is just going to be a 0.05. And so we go 0.05, which is what this very last column. And then again, we'll use 40 since we don't have a 39. 66.766. 66.766. And so now we got to crunch the test stat and see where we fall. The chi-square test stat is going to look familiar. That's it. It looks a lot like the confidence intervals, right, that we used. No square root, none of that. N minus 1, we'll still go ahead and use 39 here. S squared is what we actually have, so that's a 4.9. This population standard deviation, that's going to be your claim value, so 6 squared. And at this point, I will say, handy calculator, come here. And I have 39 times 4.9 squared. That is my numerator, and I will divide it by 36. And I get a 26 point something or other. Doesn't really matter because I land in here, which is definitely my green zone, which means I fail to reject the no. So I keep my no, which makes us happy because that means I am right, that the standard deviation appears to be 6 pounds for everybody. I've used Weight Watchers, and it actually is very good if you do what they tell you to do. So I would recommend it. But this was, so we were very happy, failed to reject, and it would appear that there is insufficient evidence to warrant the rejection of my claim if we use the fancy chart to figure out how this should be worded. It had the equality. We did not reject it, so there's not sufficient evidence to warrant the rejection of the claim. Or a lot of people would say the sample evidence supports my claim. So now what? in your handy dandy 8 lab, I walk through 2 examples and then, well, one of each. So I did one problem, and then you'll need to do it twice more. My story is that I had this many people. I gave 5 people vaccine A, 5 people vaccine B, 3 people nothing. And this is from the book that I know I've spoken about a couple times, Rainbow Six, where we gathered up some homeless people and we sprayed them in the face with Ebola, and then we counted. And vaccine A people, looks like they may have bought themselves some time with the vaccine. Vaccine B looks fantastic. They never displayed any symptoms. Control group, probably not feeling so great at the moment. And so what we are going to need to do, because we're going to be running t-test, and you're going to be running chi values, is you're probably going to want to go ahead and put this guy into L1 and this one into L2, because what you'll need to do is run it for like untreated and treated. I broke it up. So test the following claim about the mean and the standard deviation of vaccine group A. So I'm just going to focus on vaccine group A. And so what I would do is I would take vaccine A's info and I'll put that in L1. I'm using a 0.025 significance level. Yours will be the standard 0.05, and maybe a 0.01 creeping around in there. And I want to say that vaccine group A, it will take them more than 30 days. More than 30 days it's going to take them. So that's my claim, more than 30 days. So that means less than or equal to is their the null. I need to get my information. It's going to be a one-tailed test because it's right-tailed. I would need my x bar and my s of x if I was going to be doing this by hand. Of course, I did not do that. I put it into my calculator and I ran my t-test. And you can use the data portion instead of running this with one vars and then going through. That will give you everything that you need. This is how you would find out this information by hand. Well, in your calculator without using the program. And so I take my p-value, 0.006 is less than 0.025. So therefore I reject the null. P is less than the 0.025. There is not sufficient evidence to warrant the rejection of the claim that it will take less than 30 days. Basically, I was right. It's going to take more than 30 days because I gave them that vaccine to slow it down. So your A's for your next 2 section will be doing that. The B's are the standard deviation with the chi values. And this one I want to say it takes at least 7 days. So 7 days or more. So I have the equal in there. So that's got to be my claim. Yours are a little more cut and dry. It's not as sneaky. So less than that is going to be my null. And I said, think about it. 1 through 7 is okay, but 8 is not. So you're saying it's going to be 7 and up. I get my standard deviation that I still had before. I had 5 data values, so my DF is 4. And you have a significant level of 0.025. So that means you got a 0.075 to the right because this is a left-tailed test. Looks like this. Right, because I got the less than, I got this 0.025 in here, I got this 0.975 over here, and on my chart, all the way down, 0.975 with a 4 gives me a cutoff value of 0.484. So that's my critical, 484. Oh, 0.484, was it right? 0.8484, super tiny. So now I need to find out what my test stat is, and that is DF times my standard deviation squared over my claim squared, and I get about a 14.42. So I am way out here, which means I'm in the green zone. So I failed to reject. That's good news for me. I failed to reject because it wasn't less than the critical value, so there's sufficient evidence there is not sufficient evidence to warrant the rejection of the claim. I have that backwards. So there is not sufficient evidence to warrant the rejection of the claim. I had changed this around a little bit. So it will be at least 7 days. So I was right again. So now what are you going to do? You have a treated group and an untreated group. The one here, you're going to go through your untreated group. You're going to put that in L1. You're going to run your t-test, do all of that. And then you're going to use that same standard deviation that you get from your t-test. So when you run your t-test, it tells you that information. Let me show you the picture. Right here. So you're going to need that for the next part. So after you run your t-test, jot down that S of x. And then you're going to run your chi-value tests for the standard deviation. And this one, it will be less than 7 days to display symptoms. This first one was it will take exactly 30 days, 0.05 significance level. And then you're just going to repeat that for your, what happened in there? Untreated for the next part. So go back through, take your treated out, put your untreated out, put that treated in, do your t-test again, mark down the new S of x value so that you can do that over here. And you can see I put these values in with the fail or reject so you can either highlight the one you want or delete the one you don't need, however you want to do it. I just wanted to make it easy for you to get your symbols in there. This is also due before the final, so this will be your extra credit lab, and that is how you do your chi values and how you will complete your extra credit lab.